Imagine a world so close to the sun that its surface melts and burns under the intense heat. Mercury, the smallest planet in our solar system, has always been a mysterious enigma. But what if everything we thought we knew about it was wrong? The James Webb Telescope has sent back images and data that challenge everything NASA has ever told us. What could they be hiding? Why did it take so long to reveal the shocking secrets buried beneath Mercury's surface? Bizarre structures, strange formations, and even signs of something that could change how we understand the entire universe have been detected. How is it possible that a planet so close to our sun could be hiding terrifying discoveries? Is NASA keeping the truth from us, or have they only scratched the surface of what's really going on? Could these new revelations shake the foundation of science as we know it? And why now? What's different about Mercury that no one saw coming? Brace yourself, because what the James Webb Telescope has uncovered might be more frightening than anyone could have ever imagined. What are they not telling us about Mercury? The answers are chilling. Mercury, the smallest planet in our solar system, has always intrigued astronomers and space enthusiasts. For centuries, its surface was hidden from us. But as technology improved, we started to uncover its secrets. The real journey began in 1973 when NASA's Mariner 10 spacecraft visited Mercury for the first time. This mission was followed by the Messenger probe in 2004, which helped us learn even more. Mariner 10 gave us our first close-up view of Mercury. As it flew by, it took images showing a planet full of craters and strange ridges, looking similar to our moon. It also revealed that Mercury has a rough surface, a surprisingly strong magnetic field, and a larger core than scientists had expected, challenging their earlier assumptions. Then came the Messenger mission: Mercury's surface, space environment, geochemistry, and ranging. Launched 31 years after Mariner 10. Unlike its predecessor, Messenger didn't just fly by. It went into orbit around Mercury, allowing for a much deeper study. It sent back 200,000 images showing parts of Mercury no one had ever seen before. One of the most interesting discoveries from Messenger was the high levels of calcium and magnesium on Mercury's darker side, which raised questions about how they got there. Another surprise was how strong Mercury's magnetic field was in the northern areas, something not seen on other planets. These findings showed that Mercury's inner structure and how it formed were different from what scientists once thought. While most planets, like Earth, generate magnetic fields from moving liquid iron in their cores, Mercury's structure causes it to behave differently. What really makes Mercury stand out, though, is the extreme conditions on its surface. Temperatures during the day can reach 430 degrees Celsius, 806 degrees Fahrenheit, while at night, they drop to minus 180 degrees Celsius, minus 292 degrees Fahrenheit. This is because Mercury has a very thin exosphere, which doesn't help control its temperature. Despite the harsh conditions on Mercury, recent studies have revealed some surprising discoveries. In 2012, data from the Messenger mission showed evidence of volcanic activity on Mercury, including signs of explosive eruptions. This finding challenged the old belief that Mercury was completely inactive geologically. Even more surprisingly, in 2020, scientists found water ice in some of Mercury's polar craters. These areas, which are always in shadow, are cold enough to keep water ice from melting, even though Mercury is so close to the sun. This discovery raises new questions about whether simple life forms could exist in these icy spots similar to extremophiles on Earth. The latest mission to Mercury, Bepi-Colombo, launched in 2018 as a joint project between the European Space Agency and the Japan Aerospace Exploration Agency, is expected to reach Mercury in 2025. It aims to provide more detailed information about Mercury's surface, its chemical makeup, and its geological history. With surprises like Mercury's strong magnetic field and the presence of water ice, there's much more to learn. And here's something that will really make you think. How can a planet so close to the sun have a year that's shorter than its day? Mercury is unique in this way. A year on Mercury, which is one full orbit around the Sun, takes just 88 Earth days. But a single day on Mercury, or one complete spin on its axis, lasts 176 Earth days. So, on Mercury, a year is only half as long as a day. This strange situation causes some unusual effects. If you were standing on Mercury, you'd see the sun rise, get bigger, then appear to stop and move backward before continuing its path. This odd behavior happens because Mercury's slow rotation doesn't match its fast orbit around the Sun. Why does Mercury rotate so slowly? Scientists think it's due to tidal locking. Over billions of years, the Sun's gravity has slowed Mercury's rotation. Unlike our Moon, which is always facing Earth, Mercury is in a 3-to-2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. This unique rotation causes extreme temperature changes on Mercury's surface. The side facing the Sun gets incredibly hot for months, while the night side remains freezing cold for the same length of time. This leads to some of the most extreme temperature differences in our solar system. Mercury has a very thin atmosphere, called an exosphere. This layer of gases is constantly being lost to space and replaced by different processes. The solar wind, radioactive decay, and tiny meteorite impacts all help maintain this delicate exosphere. Recent studies have uncovered surprising details about Mercury's exosphere. In 2020, data from the Messenger spacecraft showed that Mercury's exosphere has more water vapor than scientists previously thought. This water vapor is believed to form when hydrogen from the solar wind reacts with oxygen in Mercury's surface rocks. Mercury's unique orbit and slow rotation also affect its magnetic field. Despite being small and rotating slowly, Mercury has a global magnetic field, which was a surprising discovery. Scientists think this magnetic field is created by a special dynamo effect in its liquid metal core, driven by Mercury's unusual rotation and orbit. Even though Mercury's magnetic field is much weaker than Earth's, it still plays an important role in protecting the planet from the solar wind. Without this magnetic field, the solar wind would strip away Mercury's already thin atmosphere even faster. Mercury's rapid orbit and slow rotation create some interesting phenomena. There are spots on Mercury's surface called hot poles, where the sun seems to stand still in the sky at certain times, creating extremely high temperatures. Meanwhile, areas near Mercury's poles are in permanent shadow and stay incredibly cold. These shadowed regions are where scientists have found evidence of water ice. How can ice survive on a planet so close to the sun? It's because of Mercury's unique orbit and rotation. The permanently shadowed craters near the poles never get sunlight, keeping them very cold even while other parts of the planet are extremely hot. This has led scientists to wonder if other volatile substances, like organic compounds, could be preserved in these cold spots. Mercury's short year and long day also make it challenging to study. Because Mercury orbits the sun quickly, spacecraft have to use complex maneuvers, including multiple flybys of Venus and Mercury itself, to slow down enough to enter orbit around the planet. The Bepi-Colombo mission, launched in 2018, will use these flybys to adjust its speed and orbit around Mercury. It won't reach Mercury until 2025, after completing 9 planetary flybys. Once it arrives, the spacecraft will need to manage the intense heat of Mercury's dayside while staying powered during the long, cold nights. New computer simulations suggest that Mercury might have once rotated faster, but was slowed down by the sun's gravity and impacts from large asteroids or comets. This research helps us understand not just Mercury's past, but also the evolution of other planets in the solar system. As we continue to study Mercury, new questions arise. How does Mercury's core stay partially liquid despite the extreme cold? What effect does its unusual orbit have on its geology? These mysteries show us that even within our own solar system, there are still many secrets to uncover. Mercury's unique features challenge our understanding of how planets form and change, pushing us to explore and rethink our theories. So, what other surprising secrets might Mercury be hiding beneath its surface? Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, led a team that made a surprising discovery about Mercury's magnetic field. They found that the magnetic field is not centered perfectly, but is shifted by about 20% of the planet's radius. This shift might be because Mercury's crust has different thicknesses, which affects how heat moves from inside the planet. The surprises don't end there. In 2020, scientists discovered that Mercury's surface has volatile elements like sulfur, potassium, and sodium. These elements usually evaporate at high temperatures, so finding them on a planet so close to the Sun was unexpected. Dr. Patrick Poplawski from the Johns Hopkins Applied Physics Laboratory thinks these elements might have arrived on Mercury from comets or asteroids after the planet formed. One exciting discovery is that Mercury has water ice in craters near its poles that never see sunlight. These craters are always in shadow, so they stay very cold. Dr. Nancy Chabot helped find this ice, which is surprising because Mercury is so close to the Sun. Even more interesting, scientists have found organic compounds in these shadowed craters. These dark deposits could be carbon-based molecules, similar to those that may have been crucial for the origin of life on Earth. Could Mercury, despite its harsh environment, offer clues about how life began in our solar system? Mercury also shows unexpected geological activity. For a long time, scientists believed Mercury was geologically inactive, but data from the Messenger mission showed signs of recent volcanic activity. Dr. David Rothery found bright spots on Mercury's surface that appear to be volcanic vents. These features, known as hollows, suggest Mercury might still have volcanic activity today. One puzzling area on Mercury is the chaotic terrain, a large region of mixed hills and valleys near the planet's south pole. This area, first seen by the Mariner 10 mission in the 1970s, is about the size of Texas. Dr. Thomas Waters thinks this terrain might have formed from huge earthquakes caused by the Sun's gravitational pull as Mercury's orbit changed. Recent studies have also revealed new details about Mercury's composition. Dr. Amir Khan found that Mercury's core has a liquid outer layer and a solid inner core, like Earth. However, Mercury's inner core is much larger compared to Earth's, which could explain some of its unique magnetic features. These discoveries challenge our understanding of how planets form and change. They remind us that even in our own solar system, there are still many mysteries to uncover. As we look forward to more missions, we wonder, what other secrets might Mercury be hiding beneath its surface? Mercury's solid inner core is about 1,260 miles, 2,000 kilometers, wide, making up nearly half of its core. This is much larger compared to Earth's inner core, which is about 20% of Earth's core volume. This size and structure of Mercury's core are important for its magnetic field, which, though weaker than Earth's, is still strong for such a small planet. Beneath Mercury's crust is a mantle that might be thinner than previously thought. Recent studies suggest the mantle is only about 260 miles, 420 kilometers, thick compared to Earth's mantle, which is about 1,800 miles, 2,900 kilometers, thick. This thinner mantle affects Mercury's geological activity and how it distributes heat. In 2012, Messenger discovered signs of old volcanic activity on Mercury. It found shallow depressions called hollows, which formed when volatile elements evaporated from the surface. This suggests Mercury's interior had more volatile elements than we thought. In 2020, Messenger data revealed an ancient underground magma reservoir. This magma ocean likely shaped Mercury's surface, including the smooth plains in its northern hemisphere, which were probably created by early lava flows. A surprising find in 2022 was evidence of nitrogen trapped beneath Mercury's surface. This nitrogen might come from an ancient atmosphere that was pushed underground by Mercury's heat and solar radiation. The presence of nitrogen raises questions about Mercury's past. Could it have had a thicker atmosphere before? What would this mean for its early climate and potential habitability? Another intriguing discovery is the water ice found in permanently shadowed craters at Mercury's poles. This ice is protected from sunlight and might be relatively young, possibly from comets or asteroids. These craters also have dark deposits that could be organic compounds from comets or asteroids. Studying these could give us insight into organic materials in the inner solar system. Mercury's subsurface shows signs of significant shrinking as it cooled, causing thrust faults where the crust pushed up over itself. This reveals details about Mercury's internal structure and geological history. Recent studies suggest Mercury might still be tectonically active. In 2019, researchers found grabens, which are valleys formed by crust stretching, indicating that Mercury's crust is still moving. Mercury's magnetic field is another mystery. Unlike Earth's, which comes from molten iron in the outer core, Mercury's field might be created by a dynamo effect, in a thin layer of liquid metal around a solid inner core. There's also speculation that subsurface faults could allow heat and possibly fluids to move through Mercury's crust. While Mercury's surface is dry, some scientists wonder if there might be liquid water below, warmed by the planet's core. As we keep studying Mercury, we face new questions. How has its internal structure changed? Are there other hidden compounds or elements? What can Mercury's subsurface tell us about the early solar system and planetary formation? These discoveries highlight the need for more exploration of Mercury. Each finding helps us understand this small, mysterious planet and the history of our solar system. What do you think might be hidden on Mercury? Gems, or maybe even signs of life? If you enjoyed this video, hit the like button and subscribe for more updates. Thanks for watching, and see you next time.